Very good afternoon. This video is going to show the solution of domain and range of function of several variables under the course multivariable calculus. I'm from Faculty of Electrical and Electronic Engineering at Universiti of Malaysia, UTSM. My name is Tay. We have the first tutorial concerned on the domain and range. The first question here, find the domain of each function. The first one is fxy equal to square root x squared plus y squared minus 4 divided by 1. We can let's create here. This one is a z equal to function of fxy equal to this square root divided by 5. To find the domain is actually set of input for this function of two variables. The input is x and y, so the domain is actually set of y, x and y that makes the function defined. Range is actually is a set of the z values. First of all, to make the function defined, if we have the square root functions, in order the square root not to get a complex number, you have to set the whatever expression inside the square root to be greater than equal to 0. Once you set x squared plus y squared minus 4 greater than equal to 0. This way you have x squared plus y squared greater than equal to 4. And you have a denominator, you have a y. In order the function to be defined, y cannot be equal to 0 because we have here, let's say, since we already set the numerator here, this is a positive square root, so the numerator value is either you have positive value or 0. So if you divide it by 0, then you have an intermediate from 0 divided by 0. Or if you have positive value divided by 0, you may get infinity. Function is defined on real value only. That's why to make the functions defined, y cannot be equal to 0. That's why the domain, you have to combine both. Domain is set of x and y such that the x squared plus y squared must be greater than equal to 4 and y cannot be equal to 0, and x is a member of real number, y is a member of real number. So with this constraint of your domain, what are set of value of z that can be obtained? So that is so-called the range. So you see that z here. We already set this is positive square root, so z is either you have the positive value or 0. Then this one will divide by y here. Y can be y cannot be equal to 0, so it can be positive or negative. Is in this way, z, the numerator is either positive or 0. But y here can be positive or negative. So you have positive divided by positive, means the z you have positive or 0. And then this one you have positive or negative, positive or negative. So combination, you will get the result here. Positive divided by positive, positive. Positive divided by negative, you get the result is negative. 0 divided by positive, these two, of course, you get the result is 0. 0 divided by anything, 0. So the z, you can have positive or negative or 0. That's why z, the range is actually set of z, where z actually belong to real number. For question B, this is a W. W is a function of three variables, x, y, z. Then we have numerator is y, denominator is a square root function. So numerator y, you can have all value, positive, negative, or 0. Okay, but for square root function, we said we must have a greater than 0. But in this case, we have to set only 16 minus x squared minus y squared minus z squared positive only, because if we set it equal to 0, if we include this one, then we have a value divided by 0, we get infinity. That's why we can only set 16 minus x squared minus y squared minus z squared greater than 0. Because denominator, you cannot have, denominator cannot be equal to 0. Denominator means, your 16 minus x squared minus y squared minus z squared, you cannot equal to 0. If equal to 0, the function will be undefined. Then from here, that's what you have 16 greater than x squared plus y squared plus z squared, hence x squared plus y squared plus z squared less than 16. So this will be the domain. So domain is actually set of x squared plus y squared plus z squared less than 16 such that x belongs to real number, y is a member of real number, z is a member of real number. Then how about the range? The range, the range is actually, you have a W, y, is a real number, y is a real number, divided by, denominator is a positive value. So a real number divided by a positive value, in this one you might have positive, negative, 0, divide by positive, divide by positive, divide by positive. The result, positive divided by positive is positive, negative divided by positive, you have negative, 0 divided by positive, 0. That's why the range is actually W is a member of real number. W is a member of real number. Question 2, find domain and range for the functions. Fxy equal to 9 minus square root x squared plus y squared plus 2y plus 1. Let it equal to z. So we have z equal to 9 minus, when do the completing the square for the last three terms inside the square root function. So we have x squared plus y plus 1 squared. Because of the square, if the x negative value, still get positive. Y negative value still positive. That's why in this case, x and y are no restriction. Can take negative value, of course positive value, because square root we want the value inside is positive, or can take 0. That's why in this case the domain is actually x is a member of real number, y is a member of real number. Because of the x squared. So x can take negative value, no problem. Of course can take 0, can take positive. Same with the y here. So no restriction at all. How about the range? Look at the range. Range Okay, Z, we have positive 9, okay, minus, okay, this square root is actually, or can be, it can be 0 or positive value. Okay, so if you can put it another way, 9 minus a value either 0 or positive. So 9 minus 0, we have 9. Okay, 9 minus a value which is positive, you get a value less than 9. Less than 9, right? You minus a value, okay, minus a positive value, you get a value less than 9, because 9 minus something. Can you have a negative value then? Of course can. Because at most you have a 9, you minus something, so that's why the value must be less than 9. That's why your range is actually Z be equal 9 minus this one is equal 9 minus 9, you get 9, so it's less than or equal to 9, where Z is a member of real number. Because this value minimum 0, and then maybe 0 0.1, 0 0.2, 0 0.3. So if you 9 minus, for example, you minus 1, you get 8, less than 9, right? So if you minus 0 0.1, okay, 8 point, okay, something. So it's a value that always less than 9. So there's a 2a. Okay, for 2b, Z equal to fxy equal to the square root, okay, 25 minus x squared minus 9 and 9y squared. Again, for the function to be defined, the expression inside the square root function must be greater and equal to 0. And once you set 25 minus x squared minus 9y squared greater and equal to 0. That's why 25 greater than x squared minus plus 9y squared, or x squared plus 9y squared less than 25. Sorry, we have equal. So less than or equal to 25. Okay, how about the range? Okay, the range. Okay, remember this is a positive. Okay, you may have your the square root. This is positive square root, and you may have the Z. This one is positive, and then factor out your negative. So x squared plus 9y squared. This. Okay, plug in your domain. Okay, domain is actually your x squared plus 9y squared less than or equal to 25, where x is a member of real number, y is a member of real number. Okay, so for x squared plus 9y squared, this one, after you square, the value is always can be minimum is 0, maximum is 25. Because you square it. So this value, minimum 0. Because less than and equal to 25. So maximum is 25. Okay. Why minimum 0? Because you plug in negative value for x and y, because of the square is always get positive. You plug in x0, y0, and of course you get 0. That's why minimum value is 0. Maximum less than or equal to 25. Maximum is 25. So when you plug in this one, when you plug in x squared plus 9y squared, put it here to see the range. To see the range, plug in the domains. X squared plus 9y squared, and this is a Z. So the minimum of the domain is 0. Plug in here, so here Z you get 5. Plug in the maximum, you get 0. Okay, that's why the range is actually your range is R Z from 0 to 5. we plug in the range, the domain minimum is 0 here. So square root 25, you have 5. Plug in the maximum value of your domain, which is 25, you get 0. That's why range is actually value of set. Value of set that we define from the domain there. So it's from 0 up to 5, included, because this one included. So this is a 2B. C fxy is ln square root x squared plus y squared. Okay, call back the graph of ln, a function of one variable. Okay. Y equal to ln x, so x must be positive, so that ln is defined. You can ln negative as in negative 1. Okay, undefined. Ln 0 also undefined. Ln 1 you have 0. Okay, ln 0 point something until 1 you get negative value. Ln 1 point something you get positive value. So the range of y equal to ln x is actually y is a member of real number. With this, you look at this one. Ln square root x squared plus y squared. Okay. This is positive square root. That's why ln positive value is defined. And then x squared you get positive, y squared you get positive. That's why here domain you have x, but when x 0, y 0, ln 0 is undefined. That's why x cannot be equal to 0, y cannot be equal to 0. But x is a member of real number, y is a member of real number. Okay, how about the range? How about the range? Okay, range. So z is actually ln square root x squared plus y squared. Okay, this value is always either positive or possibly I cannot 0. Then this one is a positive value only, cannot be equal to 0. So you have something like ln a positive value. Okay, ln a positive value. So for ln positive value which is not equal to 0, the range is actually all the real number. Range is all the real number. Okay, that's why range here, range is actually z belong to real number. The fxy, let z equal to fxy equal to 1 over square root 49 minus x squared minus y squared, similar to equation 1b. Okay, denominator cannot be equal to 0, and square root function you must have greater than equal to 0, but it is at the denominator. That's why you can only set 49 minus x squared minus y squared is positive, but cannot equal to 0. Because equal to 0, 1 divided 0, you have infinity. That's why 49 greater than x squared plus y squared, or x squared plus y squared less than 49. So this is a domain. The domain will be x squared plus y squared less than 49, but not included, such that x is a member of real number, y is a member of real number. Okay, the range. So Z is actually 1 divided by 49 minus, factor out the negative side, plus x squared. Okay, x squared plus y squared is always positive. Minimum is 0. The minimum is 0, maximum is 49. So we can put out the value for the domain x squared plus y squared, and then this is a z. Okay, x squared plus y squared less than 49. Minimum value is 0. Okay, maximum value is it's actually, this one is, you can put 48.99 something. Okay, so when you plug in x squared plus y squared equal to 0, you get the answer. This is 1 over 7. Okay, less than 49. If let's say I plug in 49, okay, easy here, I put it, the value less than 49, I put 48. So this one you will get 1, because 49 minus 48 is 1. So square root 1 is 1, the answer is 1. This one you get infinity. So means the value increase 1 over 7 until positive infinity. That's why 1 over 7 is a minimum value. That's why the range is actually z greater and equal to 1 over 7, such that z is a member of real number. Increase when exactly 49, 1 divided by 0, you get positive infinity. That's why 1 over 7 is a minimum value until positive infinity. That's why you can write z greater than equal to 1 over 7. This is 2d. 2e is similar. You have an expression at denominator. So you can only set x squared minus 2y greater than 0. Cannot include 0. Because it includes 0, you have 1 divided by 0. You have an infinity. So that's why you only set x squared minus 2y greater than 0. So x squared greater than 2y. So x squared divided by 2 greater than y, or y less than x squared over 2. So this is a domain such that y less than x squared over 2, where x is a member of real number, y is a member of real number. Okay, for the range, you know the second is 1 over x squared minus 2y. Okay, denominator value is either 1 divided by 0. Because they cannot have 0, we get infinity, that's why we said this square root is only positive. So 1 divided by a positive value, that's why your z is actually only positive value. Okay, that's why the range is actually positive value. Z is greater than 0. Where z is a member of real number. Okay, I cannot get the square root here equal to 0. For 1 divided by 0, you have infinity. So the square root here, that's why you only set positive. So 1 divided by positive number, you get positive number. That's why z is actually positive number or greater than 0. We move to the next one. 2f, let the z equal fxy equal to ln 1 minus x squared minus y squared. Okay, for ln to be defined, you have to set the expression inside the ln positive. So that's why you set 1 minus x squared minus y squared positive. Look at the graph of ln. Okay. Must be positive only. Positive. Cannot equal to 0, cannot be negative value. That's why you have 1 greater than x squared plus y squared, or x squared plus y squared less than 1. So this is a domain. So this is a domain. X squared plus y squared less than 1, such that x is a member of real number, y is a member of real number. Okay. So again, for x squared plus y squared less than 1, okay, you have the value from 0 and then less than 1. So we try to look at the set of the exact value. So I'm going to put out like this. Okay, so this is x squared plus y squared, which cause the z. Z is a ln 1 minus, factor out negative. When x squared plus y squared is a minimum value 0, so 1 minus 0, so ln 1 would be 0. Okay, ln 1 we get 0. And then we have this value must be less than 1. Let's say put 0.9. So ln 1 minus 0.9, we have ln 0.1. Okay, look at here. Ln 0.1, we have a negative value. Ln is a negative value. Okay, or you want to calculate. Use a scientific calculator. Okay, ln 0.1, negative value, negative 2.30. If you put exactly equal to 1, but we know it actually less than 1, let's see what happens. Ln 1 minus 1, ln 0. Ln 0 is actually goes to negative infinity. When it approaches 0, ln value approaches negative infinity. That's why the value maximum is 0. Maximum is 0, decrease to negative infinity for your z. The z value is actually decreasing here. Decreasing here. From 0, decrease up to negative infinity. That's why the range is actually z less than and equal to 0, including 0. From 0 decreasing up to negative infinity, that's why the range is z less than equal to 0, where z is a member of real number. And then 2g, let z equal to fxy equal to 1 plus sub 25 minus 9x squared minus 16y squared. Factor out negative. So square root function, we set it. Well, this is in numerator only. 25 minus 9x squared minus 16y squared greater than equal to 0. That's why you have 25 greater than equal to 9x squared plus 16y squared, or 9x squared plus 16y squared less than equal to 25. Okay, and then for your domain, this is a domain. Domain, exactly, you have 9x squared plus 16y squared less than or equal to 25 such that x is a member of real number, y is a member of real number. Okay, and then you see set of value of z. I put 9x squared plus 16y squared, and this is a z. Okay, against 9x squared plus 16y squared is always positive. So minimum can be 0. Because when x 0, y 0, minimum 9x squared plus 16y squared you get 0. Okay. Maximum up to 25. From 0 up to 25. So plug in 9x squared plus 16y squared equal to 0. You have 1 plus 25 minus 0. The answer is 6. Okay, plug in. Okay, or you want to plug in this one is 25. So 25 minus 25 is 0. So answer is 1. So that's why z is actually range from, or your range is actually z value 1 up to 6, where z is a member of real number. When 9x squared plus 16y squared minimum value is 0, z you get 6. When you have a maximum value 25, z get 1. So z is actually range from 1, including 1 and including 6. This is z. Okay, for x squared plus 2y squared minus 1, you can break it z equal x squared. Okay, look at the quadratic graph. Okay, this is a z, this is a x. So for here, in x is actually belong to real number because you can take negative, 0 and positive value. Okay, and then if you look at this is y, this is z, then equal to 2y squared. Also y is a member of real number. Okay, therefore, okay, if first of all, let's say z is actually x squared plus 2y squared. Okay, you get actually this 3D graph is what we call paraboloid. You can combine z-x plane, z-y plane, you get 3D graph. This is x, this is y, this is z. First of all, you plot this one. This is z-y plane. Let's say I plot another one. Plotting is not that good. You combine, you get this paraboloid. Okay, paraboloid. So this is for z equal to x squared plus 2y squared. Okay, for this one, for z equal to x squared plus 2y squared, the range is actually z greater than equal to 0, where the z is a member of real number. Okay, but if you have now z is actually x squared plus 2y squared minus 1, minus 1. So this paraboloid will be shifted down 1 unit. So your graph is actually, the paraboloid is actually at the bottom. This is negative 1. This is x 1 z. That's why the range is actually, and the paraboloid is actually open. Okay, minimum point is z equal to negative 1. That's why z greater than equal to negative 1, where z is a member of real number. Because this graph is actually combination of z equal to x squared. In 2D is one parabola, if z equal to 2y squared is also one parabola when you combine it like this, and z move down 1 unit. So the whole thing move down 1 unit. So the range, you get z greater than equal to negative 1. Okay, recall back in 2D for your quadratic graph. This is y equal x squared, or y equal x squared. Okay, the range is actually y greater than equal to 0. So for y equal x squared plus 2, minimum point from 0 shifted up 2 units. So the range becomes y greater than equal to 2. This is for 2D graph. Now we have this one is 3D. Okay, and then here, copy this first. I have this one. Let this is z equal to fxy equal to sec 9 minus x squared minus y squared plus 1. Okay, square root functions is sec 9 minus x squared minus y squared greater than equal to 0. That's why I have 9 greater than equal to x squared plus y squared, or x squared plus y squared less than equal to 9. Okay, and then we determine the range. Okay, remember the square root function of one variable. This is y equal to sec x. So the domain x must be greater than equal to 0, so that the square root functions is defined. Then when x 0, you notice square root 0 you have 0. So let's say when x is 1, square root 1 you get 1. When x is, let's say, 4, square root 4, you get 2. So the value is from minimum 0, keep on increasing until positive infinity, or we said the range is actually y greater than equal to 0. So similarly, this one we have z equal 9 minus x squared plus y squared. So plus 1. I put out the 9, put out the domain. Okay, when the domain is x squared plus y squared, what happened to your z? Okay, x squared plus y squared is always positive. So it can be 0 or maximum is 9. So you have 0. Increase up to maximum is 9. Okay, plug in x is 0. Okay, plug in x squared plus y squared is 0. So you got sec 9, which is 3. 3 plus 1 you have 4. Okay, plug in the maximum value of x squared plus y squared, which is 9. So sec 9 minus 9 we have 0. 0 plus 1 is 4. Okay, that's why the range is actually z is from 1, including 1, including 4. Then z is a member of real number. So we have seen several examples on how to find domain and range of function of two variables, including the square root function, ln functions, quotient functions, or the normal quadratic functions. So with this, thank you for your attention.